something about Substrate.
Yep, so I'll give you an overview about what Substrate is. So, yeah, I'm Logan from Web3 Foundation. I'm part of the technical education department. My background is as a full stack developer with smart contracts and some education and entrepreneurship. So let's just jump right into what Substrate is. So, first off, Substrate is developed by Parity Technologies. It's part of the work that has come out of Polkadot, which is the project that Web3 Foundation is kind of stewarding right now, along with some other initiatives. But basically what happened was that Parity Technologies has built blockchain clients for the Ethereum blockchain, the Bitcoin blockchain, the Zcash blockchain. And so when they started building the Polkadot blockchain through learned experience, they realized that if they abstracted a lot of the core components out of the blockchain client, they could create Substrate, which is a framework for creating blockchains. So what is Substrate? The one sentence kind of tagline for Substrate is that Substrate is an open source, modular, and extensible framework for creating blockchains. So what does this mean? It's modular and extensible. So it means it packages all the core components of a blockchain for you and allows you to code just the runtime logic. So what comes in Substrate is the database, the networking, consensus engine, transaction queue, and then a library of runtime modules that you as a developer can use and compose into the logic of your blockchain. And all of these pieces can be customized or extended. So what is the runtime? So the runtime is the state transition function of the blockchain. You can also think of it as the block execution logic. So between one block and the next, it's essentially what's determining the new state of the chain from the old state of the chain, plus the transactions. And this runtime is composed out of the runtime modules. So if you look at the diagram, you can see the runtime kind of nestled in this like larger square of WebAssembly and the consensus. So the runtime is composed of these pieces. For Polkadot, it's the governance, it's some governance logic, some staking logic, shared randomness logic. But as I'll show, there's more modules, and it's also fully extensible, so people could build more. So Substrate comes with a library of runtime modules called the Substrate Runtime Module Library, or the SRML. And so these are like the pre-built, packaged modules that contain a lot of the more basic logic that you would need for creating a blockchain. So stuff like balances, so making transfers of currency, but also stuff to do with governance like democracy or the council. And as a developer, you can kind of pick and choose which one of these you want to put into your blockchain and create your own runtime from that. So the runtime is written in Rust, and it compiles down to both native code and WebAssembly. And then the environment around that, so the networking code and the WebAssembly, that's written in Rust, and that compiles just the native code. It doesn't need to compile the WebAssembly, and I'll tell you why. But first, let me say why Substrate is built in Rust and WebAssembly. So why Rust? So Rust has really great integration with WebAssembly. It builds straight to WASM. It allows for the runtime to be built into both native code and WASM code from the same from the same written code that you as a developer write. It has no garbage collection. It uses this notion of borrowing. and it's optimized to create small WASM files, which will be important because those actually go on the chain. So why WASM? WASM is a platform-independent executable format. So for blockchains, which are expected to be a distributed system, people will be running it on different architectures and different operating systems. You want something that is independent of the architecture that you're running it on. So that was, WASM was a good choice for that. It's fast and efficient, sandbox, so it's safe, it's compact, and it's well supported. So the major browsers support WASM, and also the W3C, which is a lot of major companies as well. One of the major kind of features of Substrate is that it enables forkless upgrades. So it allows, so since the state transition of the blockchain is this blob of WASM code, the runtime, that the runtime compiles down to, you can basically swap out that WASM blob from one block to the next and completely change the logic that your blockchain is executing. So how this works is that if you're running a Substrate client and the runtime logic gets upgraded, a blob of WebAssembly code will be placed on chain, and you will execute against the WebAssembly code using the WASM interpreter. So it's a bit slower than doing the native code execution, but all you have to do is go download the next client software, and then you can start executing with the native code instead. But this is how the upgrades work without needing to actually download the software beforehand. Yeah.
So one of the issues around any upgrade scheme is that the contract itself is gaining its credibility by virtue of the fact that everybody participating in the contract can see what the logic of the contract is. So any upgrade of the contract, the crucial question is, where does the permission to cause the upgrade happen, and can you build governance around the exercising of that permission?
Yep, that's a great question. So actually, I was about to go into that.
Okay.
So as like an example of like a runtime upgrade. So we'll start with a blockchain that is basically ran by a dictator. It's using what's called the sudo module, which is, if you're familiar with sudo on Linux, the power user. So the sudo user can do anything on a Substrate chain. But let's say we want to change this blockchain from being a dictatorship to a democracy. So how we can do that is we can basically just swap out the sudo module and put in the democracy module. And using the sudo key, the dictator can basically give power to the democracy by proposing this new WASM code. And that's basically how you can change the governance like that.
Yeah, just as a quick comment, that within Substrate, there's this idea of permission functions. These are functions that can only be called and executed from within the runtime logic. And so the two modules you demonstrated, democracy and sudo, are different mechanisms, but both have the ability to execute privileged functions, like what would be needed to do a runtime upgrade. So whether you want to wrap your execution logic in some kind of democracy vote or some like one user vote, whatever, only within the runtime you have the power to execute that, and it's up to your module to determine what that logic is.
Okay, good, thank you.
So now is demo time. So I'm going to do a runtime upgrade. So I have a, let's see if I can bring this over here. Cool. Okay, so this might be, okay, so I have a Substrate chain running. It's running in developer mode, and I have a UI connected to it. So this is the kind of starter Substrate UI. I have a single account, Alice. Right now, Alice is the dictator of this chain. She can basically initiate a pseudo module to make the runtime. If we look here, we can see that Alice has a ton of funds and 0 amounts. So this is so far a new chain. We'll use this module in a minute, but first I want to just show some logic of what actually this chain is doing. So this chain is a NFT chain or a collectibles chain. So if you've seen Sean's Substrate Kitties Workshop, this was based on that. So instead of kitties, though, it's fighters. So it's like barbarians, and we collect fighters. So I'll create a couple of these.
Check your console. Your console on the browser. Maybe you just need to refresh the page again.
Yeah, I think so. Oh, I know what it is. So, let's see. So, sorry, I needed to change something here. I haven't actually upgraded yet, so we're not on version 2. We're on version 1. Save that. Go back here. Okay. Okay, there we go. So I created a non-fungible token, more or less.
If you create another,
Yeah, I'll create it. I'll actually need 2 of them. So I'll create another. So it's basically just this kind of avatar-looking thing with a integer attached that I'm calling string. So here's another one, and this one has the strength of 0. Okay, and here's a third with the strength of 66. Okay, so now this is cool, but like, what can I do besides just collect these? Let's say I wanted to implement a way to fight the fighters. So I'll see if I can do some live coding here, and I'll show you like roughly how how you would implement a new function into your logic, and then upgrade to that logic, and while the chain is running. So the first thing I'll do is okay. So I'll so I want to make my fighters fight, and I want to determine which one of the fighters wins the fight. So I'm going to add a new field on the fighter struct, which is just the number of wins that this fighter has won. And instead of V1, this would be fighter V2. The next thing I'll do is I'll change the current fighter versions from V1 to V2. And then I'll make a storage item. So with Substrate, to do storage items, you can store hash maps, you can store just values. This is how you do it using a module, and it kind of looks complicated with the generic types, but really that's kind of just boilerplate. So I'll implement this. I'll give it the same getter function as the old version, and I'll just map the hash to the new fighter structs.
You just deleted a flash.
Okay. V2 maps hash to And so I'll use the same getter for the new version of the fighter truck, and that way the rest of the logic, when it tries to get the fighter, it'll retrieve the new storage item instead. So the next thing to do would be to add a storage item for the version number. So I'll add a getter. So to get that out, get version, and that's just going to be an integer. So before I do the fight function, we still need a way to migrate all the old fighter structs that are in storage to the new fighter structs that we've made. So Substrate has these hooks. It has an onInitialize and onFinalize hook. And what these hooks do is that at the beginning of the block, the onInitialize hook runs, and at the end of the block, the onFinalize hook runs. So you can use these to kind of put logic that you want to run on specific blocks without needing to send transactions to do it. So we'll use the onInitialize hook to migrate all the fighters. Okay. Let me just make sure I get this right. Okay, so actually I'll just avoid mistyping. I'll just copy this over. So this is the onInitialize hook. We'll run at the beginning of the block. All it's doing is checking that if the version is if it hasn't been upgraded yet, so if it's still version 0, it will iterate through all the fighters. It'll take it from the old storage item, from fighters V1, it'll take that out, and it will copy the fields over, add the new field for wins, and it'll store it into the new mapping for fighters V2. And then at the end, it'll update the version, so just one runs once. And so the next thing I want to do is actually implement the fight function. So the fight will take an origin. So in Substrate, the origin is the origination of the transaction. So it can be either a signed message from an account, but it could also be an inherent, which means it didn't originate from an account, it originated from another module. It could also be not signed, which means it was like a privilege call.
Yeah, the three types of origins are there's signed, inherent, and then I guess yeah, or like the self, or like the privilege function.
Yeah.
So
you just basically have to pass the origin as like the first argument, and then.
What is the origin used for?
So it's used to check the signature.
Basically, every function at the very beginning, you must know, you must define to it what kind of message you're expecting to receive. So if you're expecting some kind of transaction where a user has signed a message, the origin allows you to say, is this message signed by a user, and who is that user?
And then it decides, based on that check, what to allow.
Yeah, basically. I mean, once you have the user account, you know it's a signed message, and you can use the user account to like do some kind of permission or whatever. And the other thing is that if you write a privilege function, it will make sure that the origin is from within the blockchain itself. So no one, like if I make a function that says it requires a certain origin, like the privilege function origin, then no other person can call it. It literally cannot be done. That's what the origin basically defines.
Okay, so I just want to point out, this is the identity-based access control model that, for example, Ethereum uses when it checks message not sender. And identity-based access control is known to have some severe problems under composition. So,
yeah, but I think the one difference there is that that origin is more generic, and you can even invent your own origins too. Again, going to origin is more of a deep topic, but the idea of in general is that Substrate makes no assumptions about like what your transaction is or where it comes from or what. You can define those things and let your runtime logic handle based on what you want to do. And that's kind of the idea. But yeah.
So you can basically implement your own origin. Here we're just checking to make sure that the origin is signed by an account, and we're retrieving the sender from that signature. So yeah, just copied over this logic for the fight function. I'll just walk through it. It takes 2 fighter IDs. It will generate a random hash that we can get a random number from. It will compare the strengths of both of these fighters. It will put it through this function, which may or may not be a good way to do it. And then it will just check which one of those fighters had the highest power from this function with the random string. And then it'll mutate the number of wins to whichever fighter was the winner. So it'll start to increment wins. Okay, so this should be the entire logic. Let me jump back to. Oops, let me jump back over here. Okay. So. Okay. So I'll start compiling this just to show you what. So you would compile at runtime into the new WASM block. I had some error, but I pre-compiled earlier, so I'll just go through and show you how runtime upgrade will do. So the first thing I would do is go up to the runtime upgrade module. I would select runtime. I would go to Substrate Fighters. I pre-compiled the version 2 earlier. So I'll select that WASM log. And since I'm sending the transaction from Alice, I'm allowed to submit this pseudo call to upgrade the channel. So I click upgrade. And once this gets mined, it'll replace that WASM blob to the new logic that I just showed you. So that's good. So these will transition over to the new fighter structs. There we go. So it basically took all the old ones out of storage and migrated into the new ones. So I basically have to point the UI to look at V2 storage now, and which I'll do. So this was from before. I changed that to a 2, and then I just tell the UI that I added this new field on the struct for wins. And come back. Refresh the page.
Look at the console.
Okay, now all the fighters have wins, and the UI is showing the new fight function. So I just take 2 of the IDs from fighters. Sending this from Alice, click fight, and now it's using the new fight function that I just implemented. And once that gets mined,
Invalid status.
Let's see. So, okay. So it looks like maybe the precompiled blob that I had might not be the right one. So,
Either way, I think that this demonstration definitely showed that one, that there was an upgrade that happened because this new wins property was made, and 2, that also you were able to migrate the storage, which is something that was pretty powerful. So like being able to just upgrade runtime may not be good enough, just logic alone. That you may, in addition to doing logic, may also need to upgrade storage, and the hooks that are available like on initialize, on finalize, will allow you to do those things that you would not be able to do normally in a smart contract platform. If you don't have hooks that at the beginning of some block do something, right? And so these kind of tools together, I think, are quite powerful for, in general, runtime upgrades or blockchain upgrades.
Yep. So I'll fix it later, but essentially
Yeah.
that was the demo, and I'll
Yeah.
jump back over to how you can get started using Substrate today. So getting started with Substrate. So there's a Substrate package, which basically comes with a node template, a UI that I just showed you, this minimal UI that can be extended, as well as all the dependencies. And you can get it from this tiny.cc URL. There's also a great collectibles workshop, which this demo is based off of, that Sean has written. And it'll walk you through the steps from the basics of using Rust and Substrate through to having a live Substrate kitties chain. And I think you can bring the kitties in auction. So some additional links. I think the developer hub is substrate.dev.
Yeah.
So if you want to get started with Substrate, just go to that URL. And then I can talk, I'll just blaze through how this would fit into Polkadot. So Substrate chains don't need to connect to Polkadot. Like Substrate chains are just their own chains. But since Substrate comes out of Polkadot, and Polkadot has a few benefits, sometimes Substrate chains might want to connect to Polkadot. So how would they do this? They would become a parachain. So Polkadot has this idea of the central relay chain and the shards, which are kind of side chains. And these are what are called the parachains. So to turn a Substrate chain into a parachain would require a library called Cumulus, and it's a super minimal library that you can basically just wrap your Substrate runtime and node using this library, and it would be compatible with Polkadot. So just a visualization of how a parachain looks. The parachain has collators, which are full nodes, and validators, which are validating that correct state transitions.
Is Cumulus like a framework for building on top of Substrate?
So Cumulus is a way to make your Substrate chain compatible with the constraints that it needs to have to connect to Polkadot. So basically, Cumulus gives you a collator node, and it wraps your runtime into a execute block function, which allows the validators to verify that the state transition is correct. So it does those two things.
I think the short summary, though, is that right now Polkadot's on development, but Substrate is available and ready for you to build on, and we're encouraging people to build on Substrate, knowing that it will be really easy for you to take whatever you built on Substrate to the Polkadot network, if that was your intention.
Yeah.
And so this Cumulus is just a step to try to make it as easy as possible to get from Substrate to Polkadot.
Yeah, so it's a framework for building on Substrate.
Yeah.
Cool, great. That's all I use. Thanks.
So yeah, also you can build bridges. So
In that last slide, do the validators belong to the relay chain or the parachain?
so the validators belong to the relay chain, but they're validating the state transitions of the parachain.
Will the before something they build on Substrate joins the relay chain, will it have its own validators?
Yes.
And then if it joins, what happens to the collators?
So it's up to how the chain chooses to do the migration. Not entirely sure yet because like the network's not live, but potentially a chain that has been running with a staking token could keep using some form of staking, not to come to consensus, but to basically do election of the collators. So there would be some migration methods. And so you can also build bridges. So in Polkadot, parachain slots can be used to be a bridge, and these would essentially be light client interpreters of external consensus. So I've talked to a few people who want to work on a Tendermint bridge, for instance. And really, from what I know of IBC, it shouldn't be too difficult to actually make IBC work with Polkadot. And that's the end. So I think we'll save any questions until after Sean's presentation.
Sure. Yeah. So, and Logan just walked you through Substrate as kind of a larger vision, as the runtime upgrades and the runtime modules. And I'm going to be talking about one of the modules that you can get when for free packaged in with Substrate, which is the contracts module. And this basically allows you to run WASM smart contracts on your Substrate chain. In general, I talk a lot faster and pretty fast, so if you need me to slow down or anything like that, just let me know, because I will go. But let me get this presenting. Yeah, so I'll be talking about smart contracts on Substrate. Let's get this one bigger. Yeah, and I will also show you a demo of how you can deploy and run a smart contract. First, a disclaimer, this is very much a work in progress. So this entire smart contracts module and the language which we use to write smart contracts is very much in flux, but this is actually a positive thing. This means that if you are someone who has built smart contracts on, let's say, Ethereum, you have a lot of opinions, or you want to try out a new platform, we're actually, this is at a point where you could come in and really influence the project and really help us kind of understand what are the needs that you have and kind of how we can improve it. So really, I recommend, even though this is a work in progress, very much try it and see what you like and dislike. Quick background on myself. My name is Sean Tabrizi. I'm working as a software developer at Parity Technologies, but my background was working at Microsoft for 4 years in identity and authentication, some cloud infrastructure. It was during my time at Microsoft that I learned about Ethereum. I was really interested in contract development, and so I got basically started in that. And then I joined Parity, where I've been pretty much the entire time working on Substrate development. Yeah, so over my talk, we'll be talking about Substrate, Rust, and WASM. I think I might skip some of these things if they're very similar to the talk we had before, but really the contracts module, Parity Inc., which is the language which we use to write smart contracts, and how you can build smart contracts. So you've already seen the Substrate. What is Substrate? It's an open source module, extensible framework for building blockchains. It has all these awesome components. The really cool part being this runtime module. Let's get this thing out of the way. And really, again, as Logan mentioned, that the runtime itself can be you can pick and choose basically what modules you want to include. And the contract module is one of those modules. So if you want to have a blockchain that has no contract system in it, you can absolutely do that. But I think a lot of people with ideas of new blockchain systems may want to have a contract layer. And it's as easy as basically importing the contracts module into your runtime to get access to that feature. So again, yeah, Substrate is built using Rust and WASM, but Substrate smart contracts are also built using Rust and WASM. And I think this is one of the things we share, a lot of the ideologies between these two. We already mentioned why WebAssembly is awesome. But let's go back to Rust. So why is Rust really awesome for smart contract development? Well, we already know that Rust builds directly to WASM, so that kind of solves one of the problems. But really, when we're talking about Rust as an ecosystem, it is much more, I think, mature and maturing compared to something like Solidity. So Solidity, its only purpose lives as building smart contracts on Ethereum, right? But you have a platform like Rust, which is being used at all different layers, web development, system level architecture, we're building blockchains with it. And there's a whole ecosystem kind of around it that's not based on only smart contract development. So as a result, you get all the tools. So like Rust integration in Visual Studio Code or other IDEs come for free because there's already an ecosystem of building Rust. So if you are building smart contracts in Rust, you get all that kind of stuff for free. Rust code in general also, if you kind of look at the philosophy of Rust, is much more ergonomic and easier to get right. So when you're talking about writing contract code, this code which is supposed to be permanent and it's supposed to basically be like free of errors or issues, that, I think if you've written Solidity, you know that that is kind of sometimes hard to achieve. Things as simple as like overflow, right? That just is crazy. Every single contract basically imports the safe mass library. Well, Rust is really built to be free of undefined behavior and make it really easy to write the code that you intend to write. But because we're using WASM as a smart contract layer, you don't need to use Rust. The platform we're building at Parity is Rust because we love Rust. But you, of course, could write your own language or interface on any language which eventually compiles to WASM and shares the same API between the contracts module and the language you're writing, right? But we'll talk about Rust because Rust is awesome, and this is what you can do today. So yeah, so in general, I guess the TLDR is open standards are better than custom frameworks. If we work in an open standard place, you get the benefits of the community, you get the benefits of all the open ecosystem. And this is true for both WASM and Rust. So let's talk about the contracts module, which is, it truly is magical. The contracts module provides the functionality basically in your runtime to deploy and execute WebAssembly smart contracts. The contracts module is very familiar, I think, to what you might know if you're working on Ethereum. It's an account-based system. Accounts have balances, some code, and some storage. There are gas fees. This is something that if you get deeper into runtime development, you'll know that by default there are no fees within your runtime. You don't have to implement that yourself. But the contracts module has a fee system kind of layer built into it to prevent, of course, attacks on your blockchain from basically people running too much stuff. There's contract storage, and then there's also revertible transactions. This is another thing that if you're building runtime modules at the blockchain level layer, we don't actually support reverting of transactions. If you have a transaction that kind of goes through and processes, that kind of state change is kind of permanent, and this is kind of basically to make it so that you have fast, fast and very performant blockchains. Whereas contracts again are meant that anyone can kind of publicly go and write contracts. So you need to add these extra protection layers to your blockchain to prevent users from being able to spam you and cause problems in the logic. Yeah, so contract deployment is a little bit different than what you might expect on Ethereum. Whereas Ethereum, you would have some bytecode and you publish it, and all that gets put to an address. We have a two-step process where the first step is to take the WASM code you generate, your smart contract, and just put it on the chain. From there, you can actually go and instantiate multiple versions of the same contract. So using a single WASM logic, you can basically create multiple accounts which have their own storage but point to the same logic. And so imagine, like, again, in Ethereum, there's 1 million people who publish ERC20 tokens. Every single time you've had to write the entire contract every time. Here you could write one ERC20 contract with some kind of initializing or constructor function and deploy it as many times as you want from that one piece of code. It really saves a lot of redundant contract code. When you call a contract, basically the code is retrieved and executed. So a contract call can do things like change the storage entry of the contract account. That's very obvious. It can create new smart contracts, and you can have these like deployer functions, right? It can call other smart contracts, but the coolest thing actually I think is it can call runtime module functions. So you can go in your blockchain and introduce new low-level functions which kind of bypass all of the restrictions of contracts and have your contract call that. So I think one common example might be in the future is like if you want to introduce a new hashing function or introduce some kind of new cryptographic function. Usually that requires like a full upgrade on Ethereum. You have to do like this whole proposal, you have to do a full hard fork or whatever. Here you can maybe introduce a new runtime module through a live upgrade, and then you can have your contract basically call into that to get access to the new function. I think it's gonna be really cool. Again, these are the kind of things, we don't know exactly how this will develop or how it will be used, but these kind of things are available. So let's talk about execution context. So basically, when you call a contract, execution context is created. Basically, that execution context has a WebAssembly instance. It has some transient memory. These execution contexts can be nested. So again, if I have a contract that calls another contract, a new execution context gets created. All of these get nested. As each one resolves, basically at the very end, the context will say, well, whether something happened with an error or without error, and then it passes that message to the context above it. And that context can actually choose if it wants to handle the error or it wants to just pass the error along. So you can basically say that you can create contract logic, which basically if any part fails, everything fails, or you can create contract logic which says if one part fails, I can handle that and continue executing in a way that I know of how to do it. And then when all the execution contexts succeed, only at that point does actual changes get committed to the substrate storage, and then it's irreversible. Yeah, so let's talk about Ink. So Ink is a rustic way to build smart contracts. Basically, it is an EDSL, which is an embedded domain-specific language, to write WebAssembly-based smart contracts in the Rust programming language. It's broken up into 3 layers. At the bottom, there's this core, which is basically pure Rust, and defines the API between the contracts module and the actual language. So this is pure Rust. And then we've abstracted it up to this language layer, which is something that's much more ergonomic to use, but something much more familiar to what you would expect something like Solidity, where basically we use a macro to ultimately convert that simple code into the core code, and then it interacts with the API layer. And one of the cool things about the way it's built here is that if you actually wanted to build your own flavor of this language, you can start with the core and then build up to your own language layer. So again, starting with Rust though, you'd be able to do something like this. So let's look at the Ink language. So it's just one macro here. So you see there's a contract macro, and within that is mostly just real Rust. There's a few things we kind of do in the macros to make it more ergonomic, but basically it's just one macro and then pure Rust. And you can see the components of this macro, or inside this macro, are what you might expect. Things like events, storage, basically a deploy function or constructor function, and then any type of public-private functions you want to implement. And we'll kind of walk through real quick what each of these different components may look like inside. So you have an event. If you want to make an event like a transfer function, and I'll be walking through an ERC20 token basically here. But if you have a transfer function, you can basically define things like from to value, and these are the kind of things that will be emitted during an event. And one of the things to note here is that common blockchain types are implemented for you. So things like account ID, balance, hash, and moment are all things that are available to you in the language.
Moment is block height.
It's time. It's the equivalent of like time. Then of course you can create storage items. So you can see here we have things like values and hash maps. But you also have like things like vectors and other things you can use. And again, you can use those types and basically define like I have a hash map from an account ID to a balance. That is what a balance is. You're very familiar if you're familiar with Solidity. Then you have a constructor function. This is a one-time function that gets called when a contract gets deployed. And basically you can do things like here we've initialized the total supply to a single user. And one thing to notice here is that you get access to common environment variables. So here we say that whoever calls this deploy function, whoever calls the deploy, will get the initial balance of tokens. And so we use environment callers. So you have things like caller, balance, random seed, gas left. These things are actually available to you throughout your contract. And then finally, we're walking through more some stuff like getters. So function visibility is explicit. So if you want to have a function which can be called from the outside, you must call it pub external and then function. And then also immutability is explicit. So here we have it as self, and I'll show you next a mutable function which uses mute self. So again, I think this is very similar to some of the things that Solidity has learned. Like you need to add these like view, or you need to add what the function is able to do. That's kind of built in a rustic way. And then Rust handles overflow checking. So this piece of code right here might be something that people would cringe at. But actually within Rust, there's just a compiler flag which you can say, if there's ever an overflow, panic. And so here we don't have to worry about importing safe math every time. You don't have to worry about all this kind of craziness. You just do math as you would expect it, and Rust will handle at the compile level to add the panicking. This is really a powerful tool. Let's jump to the transfer implementation. So basically, I just want to show you here that this is the function privacy. So this is the internal function. This is like that the transfer and transfer from all both call this. And this function is not accessible from outside the contract because it doesn't include the pub external. So this is an internal function. And then finally, tests. Another thing is that I think the testing framework for Solidity is completely on the side. Like I think most people use Truffle, and it has their own kind of third-party testing platform. Here, we just get to take advantage of Rust, the Rust platform for building tests. So we have basically this test environment that we've generated, which is like a pseudo blockchain, and you could just use that and run normal Rust tests to test all of your functionality and features.
Could you describe environment test set caller? What is environment caller used for if you can set the call?
Yeah, set caller. So here's in the test world, set caller basically sets who end caller would be in the logic. So here, in my test, I'm saying set caller to Alice, and then I call deploy function. And if you look at the deploy function uses the caller to set the balances, the initial balance. So basically I've said, tell the deploy function that end caller is going to be Alice. So I could make it Bob instead, and it would treat it as Bob deployed the contract.
So,
that make sense?
What I'm wondering is, if set caller is part of your runtime, how is it that caller is a check with integrity?
No, this is just a test. This is only available through tests.
Only available through tests?
Yes,
Okay.
yeah. This set caller this is the low level end test. It's only something that's available when you make write tests. And something that you would need to write tests with, right? And so I wanted to play contract, but I don't think we'll have time. Is there someone after me? No?
Maybe people also have questions.
Yeah. I mean, I would love to real quick to deploy contract, and then also can ask questions maybe let me deploy contract. I think it would be pretty quick. So very similar to what Logan showed you. What I'm going to do, and this is probably not big enough. Let me make this bigger. I'm just going to start a node real quick. So substrate -dev. And so start a node, and we'll see here, if I refresh this page, a node is running block 1 brand new. Oh, come back to me. What happened? Nope, I think it's just loading. Okay. Yeah, so here's a node that's running. That's cool, and what I ultimately want to do is use this contracts UI, which we have built in, to basically go and publish new code. So if I go to this code, no code hash is available, I can upload some WASM. So how do we generate some WASM? So let me real quick jump into the Ink project. So this is the repo, which basically, or the project that we basically program all the Ink language in. And within that, you can see there's an examples folder. And there's examples in all the different components of Ink, the core, the lang, the model. But I'll show you the lang because that's the interesting part. And we've already kind of walked through it, so I won't show you in detail the contract. But every piece of code I showed you came from this contract, which is basically an ERC20 token built on the Ink language. So all I'm going to do here is just build this contract. So I'm already in this ERC20 folder. It already works. I build the contract, and what it will do is generate in my target folder a WASM file and a JSON API. And let's take a quick look at this JSON API. Oop, there are multiple JSON formats. I want to use prettier. Okay. You can basically see it's kind of things what you expect from a normal API. So it has like a name of the contract, what the deploy or the constructor function expects as an input, what the different functions you can call are, the message functions basically here, and their selector, it's like the hash of the name, basically to make sure that you have the right thing, and then what the arguments for it is and what kind of return type they might expect. All things we expect. So if I actually go through and upload a WASM, so I can upload it based on print, I'll pick Alice as uploading it, and I'll pick the compiled WASM, this pruned, and you can see it's built today at 5:01 p.m., and today, right now it's 5:02, so this is the one I just compiled. I'll upload some WASM, I can add some tags. This is kind of a new UI for me, so I'm actually not exactly sure what tags are, but I'm pretty sure it's just something that's on the UI side if you want to be able to search through your contracts more easily. I upload the JSON as the API, and you can see here that it already shows me all of my functions and kind of what it expects. And then I need to, of course, deploy with some gas. So I'll pick 500,000 gas, and I press upload, sign and submit, and it'll think for a little bit, and hopefully finalize contract code stored. And what you'll see now is I have this WASM stored on the blockchain. But that's not the final step here, right? This is just putting the WASM on the chain. From here, we want to actually deploy the contract. We want to make an instance of this contract, right? It's a two-step process. So what I'll do is press deploy. Again, with Alice, I can again have the default tag or whatever. And you can see now I have a deploy function, right? What is the initial value I'm going to put for this contract? So I'll say that Alice is going to start with 1337 balance. One of the things that I mentioned is that these contracts are accounts, right? So one of the things we have built in Substrate is this idea of existential deposit, which basically, when an account's balance goes below a certain threshold, we clean up the account for you. This solves the problem of dust accounts, where the accounts have so few balance in it that it costs more to remove the balance than the balance is worth. And this ends up with tons of storage space wasted in these trees, right? So we actually clean up these accounts for you. But a smart contract has the same thing. In addition, smart contracts will have the idea of storage rent. So again, one of the problems in Ethereum is that if you put a smart contract, it's basically free when you think about enough time, right? No matter how much it costs up front, the infinite time of a contract being on Ethereum makes it free. Here, the contract will be charged for just having storage for existing at all being used. And this basically endowment gives it some funds, and as it gets used, that endowment goes down, and it's up to the community to continue to give it funds if that contract is useful to the community. That makes sense, right? So I'm going to give it some initial endowment, and I'm going to put some gas to deploy the function. Let's deploy this, and it will create a contract. Oh, I have to press submit. My bad. This UI is not meant to be blown up like this, but yeah. So you see a bunch of new stuff happens. Contract is created, some contract is transferred, all that kind of stuff, right? And now we have this new part of thing, a contracts thing, where we can go and actually execute. So here you can see this is the address where you got the contract got deployed. These are the functions you can call. I can actually press execute. So I'll have Alice first call the total supply function. I don't need to send any value, because this would be like if I wanted to send some value to the contract call, but I do need to pass some gas. So I'm just going to pass some arbitrary number. And what I should expect is if I go back to this console, that you can see here that this total supply got returned 1337. So there is a total supply here. And let's do a balance transfer, right? So I have Alice now who wants to send funds to Bob. So I have Alice, and Alice will send to Bob a value of 42, right? And we will submit this again, call. Right? Okay, and it's succeeded. Now how do we test this? We can go have Bob call on his own account, because Bob can be the one to do this. So Bob will go and call the balance of, and he can pick his account as the balance of. So this before I was showing total supply. Here I'm showing the balance of Bob's account. And I can press call, and I will see, hopefully, this is done in the UI. Where is it? Scroll down. Yeah, right here. Account ID with this account ID, that's Bob, has a balance of 42. We're still working to improve the interaction experience. Like, obviously, it's kind of crazy to go back and forth between your terminal. You also notice that I actually made real transactions, so it cost me gas to like view things. We will actually have a RPC, which has a view RPC also. Those are all things that are being developed. But the idea is here that we have a WASM, it's a smart contract, we deploy it with this module, we execute it, it works, it's awesome. Yeah. Let me jump to I think I have one more thing to show. So we have a workshop too, so similarly you can learn how to do runtime development, you can also learn how to do contract development. Again, this contract space is much more kind of in flux compared to runtime development, so we would still love to get feedback, but in general, if you want to do what I've done here, build the ERC20 token, deploy it, you can do so with this contract workshop. And finally, again, to kind of give you an overview of everything we talked about today, we talked about Substrate, we talked about Rust and WASM as tools that power both contracts and the runtime. We talked about how the contracts module and modules in general can be plugged in and out of your different runtimes, your blockchains, how Ink language can be used to write smart contracts in Rust, and how you can get started building on both runtimes and on contracts today. And yeah, we're hiring /jobs/newsletter for events and updates, and we can ask us questions if we can tolerate
There's
it.
another talk, questions. I have a question actually.
Yes, please.
When you do, when I looked at this, the workshop, for instance, I asked myself immediately, if you use the Decal storage, Decal module, the logic behind this is all hidden, which is cool. It's super easy, you can use it. But did it ever already happen that people ask you hey, I want to do this particular thing, but generate the Rust code or it's called the
Macro manager?
the
Yeah.
macro, exactly. It doesn't fit my needs. Can you change this and that?
Yeah.
Or did this already happen, or do you expect this to happen regularly?
Yeah, so this is talking about contract development. So one of the big differences I just want to make a clarification is that the Ink language really has a philosophy of using minimal macros. We only have one macro. But if you look at runtime development, there's a lot of macros being used to help you simplify the generation of the underlying Rust logic. One thing I want to mention is that you can absolutely always write the pure Rust code. I mean, macro, all it does is generate Rust code. So at any point, you would be able to do whatever Rust allows you to do. There are some things that the macros don't support, people want to try to do. I think examples of this is in the storage macro, people want to support doubly linked lists and stuff like that. And we have support for it in the background, but we didn't add support for it in our macros because it wasn't being used enough, stuff like that. And that's just basically a pull request. Someone can just improve the macro and make it. But macros are kind of already complex and kind of hard to manage. We don't want to overly make things too big. But again, always you can write the Rust code. Always it will validly compile. Yeah. Any other questions? Yes.
Do you imagine there'll be just one giant smart contract parachain, or a bunch of them that compete with each other, or how do you think this will play out?
I think there are intentions for there to be parachains which act as smart contract playgrounds. So I think the best example of that right now is Edgeware, which is its entire platform is basically trying to build a smart contracts parachain where anyone can go and use it, interact with smart contracts, that thing. I think that in general, a lot of different blockchains building on Substrate may choose to include a smart contract layer as a way to interact with their community. So you may imagine, here we have some DApp chain, which is a CryptoKitties, something like that, right? And you might want to allow people, and that CryptoKitties logic may live at the runtime level, so you get all the performance benefits of basically building a blockchain versus building a smart contract. But you might want to allow people to build smart contracts which can do their own auctions, their own decentralized exchanges, their own whatever wrapping around the actual runtime logic, and I would expect at that point people would use it. But I don't think everyone's going to have a fully open, permissionless smart contract platform like Ethereum. I think that people will use this as just one of the tools to develop on blockchain technologies. Yeah. Yeah. Any other questions? No? Cool.
Thanks.
Yeah.
Thank you.